Hello students, how are you all? I hope that you all are good. The series of units and measurements is going on and we have successfully finished the 3 lectures. In a previous lecture, we have discussed about a principle of homogeneity of dimensions. In that lecture, we have discussed about how to find the dimensions of a given constants. Okay, so that is one of the important lecture. So that's why we are solved those that much of examples in that lecture. Okay, so the series is going on. This is the fourth lecture of units and measurements. In this lecture we are going to discuss about applications of dimensional analysis. Okay, what are the topic today? Applications of dimensional analysis. So in this session we are going to find out correctness of a given equation. Okay, and to convert the units from one system to another system, that means SI to CGS, and how to find the relation between given physical quantities, and all these things that we are going to discuss in this session. Okay, right. So my name is Rakesh Kanaganti. Welcome to our beautiful physics channel, Rakesh Sir Physics. Okay, shall we start? Right. Okay, so what is the session going on? Units and measurements, class number 04. Units and measurements, class number 04. Okay, so what is the topic today? Applications of dimensionals. Applications of dimensional analysis. Okay, so the first application number 1, right? So the first application is dimensional analysis can be used to check the correctness of a given equation. What is the first application? Dimensional analysis can be used to check the correctness of a given equation. So by using this, we can find whether the given equation is dimensionally correct or not, right? So let us see the example. So simple example I'm going to take, that is equation of motion. S is equals to ut plus half at square. Check the equation is dimensionally correct or not. Have to check whether this equation is dimensionally correct or not. Let us see the solution. What is the given equation? S is equals to ut plus half at square. This is the given equation. What is S? S is nothing but what? Displacement. Okay. U means what? Initial velocity. What is T? T means time. And A means what? Acceleration. A means what? Acceleration. Okay. What is S? S means displacement. So the dimensional formula of displacement is what? L, which is equals to U means what? Initial velocity. What is the dimensional formula of velocity? Distance by time. T. T means what? Time. The dimensional formula for time is capital T plus half. Constant has no dimensional formula. So what is A? Acceleration. What is acceleration? The rate of change of velocity. So what is the dimensional formula for acceleration? L by T square. So all these things that we have discussed in our previous session. Okay. And lecture number 2. T square. T square means what? Time square. The dimensional formula for time square is what? t square. Are you getting? Right. Okay. So shall I rub this? Okay. So have a look here. T get cancelled out. Here t square get cancelled out, and finally we get L is equals to L plus L. What is the power of L? 1. Power of L is how much? 1. What is the power of L? 1. So what we got? L power 1 is equals to L power 1 plus L power 1. Both sides, the physical quantity, what is the physical quantity here? Length, has same dimension. Same dimensions. Have a look, 1, 1, 1. Therefore, hence, given equation is dimensionally correct, because we got both side physical quantity is what? Length, length, length. What is the dimension? What is the power of that physical quantity? 1, 1, 1. So physical quantity is same and its dimension is also same. Hence, the given equation is correct. S is equals to ut plus half at square is a correct one. Is it clear? Right. Let's see the second example. I'm taking one more equation, that is t is equals to 2 pi into under root L by G. T is equals to 2 pi into under root of L by G. So where t tends to time period, t tends to what? Time period, and L tends to length, and G tends to acceleration due to gravity. Okay, right. Pause the video and solve this question. Pause the video and solve this question. 3, 2, 1, go. I'm going to solve the question. Have a look. So what is the given equation, ma? Solution. T is equals to 2 pi into under root L by G. We have to check whether this equation is dimensionally correct or not. Okay. So just I'm squaring on either side. So we get T square is equals to 4 pi square into L by G. Right. If you make the square on both sides, square root get cancelled out. Okay. Are you getting? Okay. So what is G? Acceleration due to gravity. L means what? Length. T means what? Time period. So the dimensional formula for time is what? Time. Time only. Capital T. It has a square. T square, which is equals to 4 pi square. 4 pi square is a constant term. Constant has no dimensional formula. Okay. So 4 pi square does not have any dimensional formula. What is L? L means length. Its dimensional formula is how much? Capital L divided by G. G means what? Acceleration due to gravity. Acceleration. What is acceleration? Velocity by time. What is velocity? Distance by time. Already one more time is there. T into T, T square. L by T square. The dimensional formula for acceleration is what? L by T square. Are you getting? Okay. L by T square. So L get cancelled out and T comes to numerator. Therefore, T square is equals to T square. So we got both sides same physical quantity. What is that? Time. And it has the same dimension. See, 2, 2. So both sides we got the same physical quantity and its dimension is also same. That is what? 2 and 2. So hence, given equation dimensionally correct. Are you getting? Okay, right then. Pause the video and write the notes. 3, 2, 1, go. Okay, right. Let us see one more example. So third example. So t is equals to 2 pi into under root of I by mb. T is equals to 2 pi into under root of I by mb. So where I tends to moment of inertia. Okay. So m tends to magnetic moment. and B tends to magnetic field. B tends to what? Magnetic field. So check whether this equation is dimensionally correct or not. Pause the video and try the problem. 3, 2, 1, go. Right. So have a look. First we have to write the dimensional formulas for IMD. Okay. What is I? I is equals to what? Mr square. What is the dimensional formula? Capital M. R means radius. Radius means distance. L square. Magnetic moment. Capital M is equals to what? N I A. N means number of turns. Constant has no dimensional formula. I means current. For current, dimensional formula, dimensional symbol, I or A, whatever it is. I am taking I. Area, L square. Okay. So magnetic field, we have the formula F is equals to QV cross B bar. B bar cross B bar. So from this we can write B bar is equals to F bar by Q into V. What is force? Force is what? F is equals to ma, mass into acceleration, L t power minus 2 divided by q. Q means what? Charge. Q is equals to I into t. Q is equals to it. V, velocity, distance by time. So here L get cancelled out, t inverse get cancelled out. So we get m power 1, m power 1. So t power minus 2, if I comes to numerator it becomes I power minus 1. So this is for b bar. We got t is equals to 2 pi into under root of I by mb, right? Any doubts? So what is t? T means time period, just squaring on either side. T square is equals to 4 pi square I by mb, square root get cancelled out. Okay, so t square is equals to, have a look, constant has no dimensional formula. I, what is the dimensional formula of I? M L square divided by M. What is the dimensional formula of M? I into L square into B. What is the dimensional formula of B? M power 1, T power minus 2 and I power minus 1. Are you getting? Right. So M power 1 cancel out, L square cancel out, I inverse cancel out. Okay. So what is the remaining term? T square is equals to 1 by T power minus 2. If T power minus 2 comes to numerator, becomes T power 2. Okay. Therefore, both side we got the same physical quantity and its power is also same 2. Dimension is also 2. Therefore, hence given equation is dimensionally correct. Okay, so I will give one homework problem, just try it. So h is equals to rho rg by 2s cos theta, where h tends to height, rho tends to density, r tends to radius, g tends to acceleration due to gravity. 2 is a constant, no dimension. Cos theta is also constant, no dimension. S tends to surface tension. S tends to what? Surface tension. So this is what? Homework problem. So try this problem and comment your answer whether this equation is dimensionally correct or not. Is it clear? Right. Pause the video and write the notes. 3, 2, 1, go. Let us see the application number 2. Application number 2. By using dimensional formula, we can convert system of 1 units to another system of units. What is that? By using the dimensional formula, we can convert system of one units to another system of units. Okay, we can convert from CGS to MKS, like that, MKS to CGS. So likewise, we can convert the system of one units to another system of units. Is it clear? Okay, right. So let us see the example of this application, right? So first example, convert convert 1 joule is equals to how many ergs, not eggs, ergs. 1 joule is equals to how many ergs, right? In a lecture number 2, at the end of the lecture number 2, I told you that about a conversion factor. Okay, so conversion factor can be used to convert the system of one units to another system of units. There I told you one formula. What is that? So n1 u1 is equals to n2 u2. I told you this formula. Okay, physical quantity is equals to n into u. Magnitude of physical quantity remains constant when it is changing from system of one unit to another unit. So we can write nu is equals to constant. N is inversely proportional to u. From there we can write n1 u1 is equals to n2 u2. All these things we are discussed in a second lecture. If you have any doubt, just search dimensional analysis 02 by Rakesh sir. You will get everything. Are you clear? Right. So joule, what is the solution? Just see the solution. 1 joule is equals to how many ergs? Ergs. Okay, right. So what is the formula we have? N1 U1 is equals to N2 U2. One thing is clear that joule belongs to SI unit system. Is it clear? Joule belongs to what? SI unit system. And erg belongs to what? CGS system. I'm just writing SI unit and CGS units. SI units and CGS units. What is the value of N1? N1 is equals to how much? 1. What is N2? We don't know. We have to find. Okay. What is joule? Joule is nothing but it's a unit. It is unit for what? Energy. Joule is the unit for what? Energy. So joule is the unit for what? Energy. Okay. Just to write, just to write the dimensional formula for joule. Okay, means energy. So energy is nothing but what? Whatever it is, kinetic energy, potential energy, heat energy, whatever you are taken, its dimensional formula is same. I'm taking a kinetic energy, half mv square. So half has no dimension. M means what? Mass, capital M, v square, distance by time, but it has square, v square. So we got a m power 1, L square, t power minus 2. So this is a dimensional formula for energy. Now for joule, mass, length, time are the units in SI system. Mass, length, time are the units for joule in SI system. That is what? First unit, U1. Okay, I'm taking M1, L1, T1 as U1. Have a look. M1 is equals to what? Kgs. In SI system, we can write mass in terms of kgs. Are you getting? Right. Here, M2. First, we write all these things. L1. In SI system, length can be measured in meters. Are you getting? And time. T1 is equals to seconds. M2. What is M2? In a CGS system, mass can be measured in grams. Okay, and the distance can be measured in centimeters, and time can be measured in, sorry, L2, this is T2, seconds. Are you getting? N1 is equals to 1, N2 is equals to, we have to find. Joule, it is a unit of SI system. Joule is a unit for energy. What is the dimensional formula for energy? M power 1 L square T power minus 2. M1 in SI system for mass, what are the units? Kgs. For length, units, meters. For time, units, second. Similarly, in CGS system, mass, grams, length, centimeter, time, seconds. Is it clear? Right. Now we have the formula N1 U1 is equals to N2 U2 to convert system of one units to another system of units. Okay. So what we have to find? We have to find N2. Therefore, N2 is equals to N1 into U1 by U2. Are you getting? N2 is equals to N1 into U1 divided by U2. N2 is equals to N1. What is the value of N1? 1 into U1. U1 means what? Unit 1. I am taking M1 divided by M2. U1 by U2 into what is the next term? L1 by L2. What is the next term? T1 by T2. Just see the dimensional formula. So from this dimensional formula, I am just writing powers. What is the mass power? 1 is there. What is the length power? 2 is there. What is the time power? Minus 2 is there. Just I am writing the powers from dimensional formula of Joule. Okay, m power 1, L power 2 and T power minus 2. What is M1? What is M1? M1 is nothing but what? Kg divided by M2 means what? Grams into L1. What is L1? Meter divided by L2 centimeter. Time second. T2 second. Power minus 2. Power 1. Power 2. Are you getting? M1 means kg. M2 means grams. L1 means meters. L2 means centimeter. Second. Okay. So I'm going to write 1 kg is equals to how many grams? 10 to the power of 3 grams divided by grams. Are you able to see the board? Okay, right. Kg is equals to 10 to the power of 3 grams by grams. Meter. Meter is equals to how many centimeter? 100 centimeters divided by centimeters power 2. Second by second. Second cancel out. 1 power minus 2. Are you getting? Okay. That is equals to, right. So here gram get cancelled out and we have 10 to the power of 3. Whole power how much? 1. Here 10 square centimeter get cancelled out and we got 10 square whole to the power of 2. And here second cancel out. 1 power minus 2 means what? 1. Its value is how much? 1. Okay, 1 power minus 2 means what? 1. Are you getting? Okay. 10 power 3 into 1. 10 power 3 into 10 square whole square. 2 to the 4. 10 to the power of 4. 10 power 3 plus 4. 10 power 7. So what is that? N2 is equals to, we got what? 10 to the power of second. What are these? Ergs. So likewise, we have to convert system of one units to another system of units. Is it clear? Any doubt? So pause the video and write the notes. 2, 1, go. So let us see the second example. Okay, so second example is capital G is equals to 6.67 into 10 to the power of minus 11 Newton meter square per kg square. Newton meter square per kg square. Okay, so convert into CGS. Find out the value of N2. Find the value of N2. So pause the video and try the solution. Pause the video. 3, 2, 1. Right, have a look. So what is the given value? G is equals to 6.67 into 10 to the power of minus 11 Newton meter square per kg square. We have N1 U1 is equals to N2 U2. This is the formula, right? So what is the value of N1 we have? N1 is equals to 6.67 into 10 to the power of minus 11. We have N1 value. What we have to find? N2. We don't know N2 value, right? What is U1? So the U1 values are what? u1 is equals to Newton meter square kg square. We have to find the dimensional formula for this. Newton. Newton is the unit for what? Force, right? What is force? Force is equals to MA. Are you getting? What is the dimensional formula for this? M L T power minus 2. Right. So from this we can write unit 1 is equals to Newton. What are the dimensional formula for Newton? M L T power minus 2. M square, meter square, L square divided by kg square, M square. Are you getting? And just written the dimensional formula for this. N is the unit for force. Force, what is the dimensional formula? ml t power minus 2. M square, meter square, divided by kg square, mass square. So mass get cancel out. So which is equals to, if m comes to numerator, becomes m power minus 1. L square into L cube, t power minus 2. So this is the dimensional formula in unit 1. Okay, for u1 these are the dimensional formulas. Are you getting? Therefore n1 u1 is equals to n2 u2. So n2 we have to find. Therefore n2 is equals to n1 into u1 by u2. n1 into u1 by u2. Are you getting? Right. What is the value of n1? 6.67 into 10 to the power of minus 11. u1, I'm just writing directly. Okay, are you getting? Right. So u1, unit 1, m1 by m2. What is the power? Minus 1. L cube, L1 by L2. What is the power? 3. Time, T1 by T2. What is the power? Minus 2. Are you getting, ma? So in a previous question, I'm just write SI units one side, CGS units another side. But here I'm just writing directly because M1 belongs to U1. In which system? SI system. Okay. So U2 is belongs to what? U2 belongs to CGS. The U1 belongs to SI. Okay, because he asking to convert CGS system. Are you getting? Right. So which is equals to what we got? 6.67 into 10 to the power of minus 11. M1 mass. M1 means mass in SI unit. What are the units for mass in SI system? Kgs. In CGS system, grams. Length in SI system, meters. In a CGS system, centimeters. Okay, next. Time, second. Okay, just write the powers. Minus 1, 3, minus 2. Minus 1, 3, minus 2. Okay, so which is equals to 6.67 into 10 to the power of minus 11 kg. Kg can be written as 1000 grams divided by grams whole power minus 1. Meter, 100 centimeters divided by centimeters. Second divided by second whole power minus 2. Second get cancel out. So here gram cancel out, centimeter cancel out. So 6.67 into 10 to the power of minus 11, okay, into 10 power 3 whole power minus 1, 10 to the power of minus 3. 10 square whole to the power of 3, 10 to the power of 6. Here 1 power minus 2. Are you getting or not? See, 10 to the power of 3 whole power minus 1, 10 to the power of minus 3, 10 to the power of 2 whole power 3, 10 to the power of 6. Second cancel out, we get 1 power minus 2. See, 10 to the power of 6, 10 to the power of minus 3. Bases same, powers will be added. 10 to the power of minus 3, 10 to the power of 6. Bases same, powers will be added. 10 to the power of 6 minus 3, 10 to the power of 3. So now this overall value becomes how much? 10 to the power of 3. So which is equals to 6.67 into 10 to the power of minus 11 into 10 to the power of 3. 10 to the power of minus 11, 10 to the power of 3. 10 to the power of minus 11, 10 to the power of 3. So base is same. Powers will be added. 10 to the power of 3 minus 11. 3 minus 11 means 10 to the power of minus 8. So finally we got N2 is equals to 6.67 into 10 to the power of minus 8. So Newton, per Newton, CGS units are what? Dyne. Meter square, CGS units are centimeter square divided by kg square. We can write gram square. So these are the units in CGS system for capital G, universal gravitational constant. Are you getting? So likewise, we have to convert the system from one system of units to another system of units. Is it clear? So pause the video and write the notes or take the screenshot. 3, 2, 1, go. Right. So let us see the application number 3. Okay. So important concept. We have the previous year questions on this concept. So listen carefully. By using dimensional analysis, we can find the relationship among physical quantities. So what is the application number 3? By using the dimensional analysis, we can find the relationship among physical quantities. Have a look. Let us see one example. Important concept. Okay. So example: force, time, and velocity V are taken as fundamental units and find the dimensions of find the dimensional formula of mass. Okay, so they are given what? For mass is depends upon force, time, velocity. Mass is depends on what? Force, time, and velocity. Now what we have to find? We have to find the dimensional formula of mass. Okay, so have a look. Means mass is depends upon what? Force, time, and velocity. So I don't know the dimensions of FTV. I don't know. Okay, so I'm just taking dimensions mean what? Power. So I'm taking the power of F as a, and the dimension of time is a B, and the dimension of velocity is C. I don't know the powers. Just for example, I'm taking F power A, T power B, and V power C. Okay, what is F? Force, time, velocity. See here, M means what? Mass. If we remove this proportionality symbol, we will get what? One constant. Let us say that constant is K into F power A, T power B, and V power C. M means what? Mass. What is the dimensional symbol for mass? Capital M. Here, at a LHS side, any time term is there? No. Time power 0. Any length term is there? No. L power 0. Just I am writing like this. Okay. So which is equals to K, where K is what? Proportionality constant. F means what? Force. Force means what? F is equals to ma, mass into acceleration, L T power minus 2 power a. This is the dimensional formula of force. I'm just written directly. Okay, if you want to know how we will get this, Check lecture number 2, 3 and come. You will understand. T means what? Time. T power B. V means what? Velocity. Distance by time. Distance by time. Power how much? C. Are you getting? Okay. So K into, I'm just expanding these powers. We have M power A, L power A, T power minus 2A, and T power B, and L power C, T power minus C. Okay. M power A, L power A, T power minus 2A, T power B, L power C, T power minus C. Minus 1 into C, minus C. So which is equals to K into M power A. Any M terms are there? No M terms. So M power A. Here L power A is there. L power A. Here L power C is there. Base is same. Powers will be added. So L power A plus C. And the time. Here T power minus 2A is there. Here T power plus B is there. Here T power minus C is there. If base is same, powers will be added. So here what? M power 1, L power 0, T power 0. Are you getting? Right. So just compare powers on either side. Compare powers on either side. So both side compare the powers. So here M power 1 is there. Here M power A is there. M power 1 is equals to M power A. Then A is equals to what? 1. A is equals to what? 1. See, M power 1, M power A. We are comparing the powers. So A is equals to what? 1. Here L power 0 is there. Here L power A plus C is there. So power A plus C is equals to what? 0. Are you getting? L power 0, L power A plus C. We are comparing the powers. Are you getting? Right, very good. So A is equals to how much? 1 plus C is equals to 0. So if 1 comes to that side, it becomes minus 1. So C is equals to how much? Minus 1. Next, T power we got minus 2A plus B minus C. What is the T power here? 0. Therefore, minus 2A plus B minus C is equals to 0. A is equals to 1. C is equals to minus 1. Just substitute here. So minus 2, what is A? A is equals to 1 plus, we have to find B minus what is C? C is equals to minus 1, which is equals to 0. Okay. Minus 2 into 1, minus 2 plus B minus into minus plus 1 is equals to 0. B is equal, B here minus 2 is there, plus 1 is there. Minus 2 plus 1, we get minus 1. Okay. So if this minus 1 went to that side, it becomes plus 1. So finally we got B is equals to what? Plus 1. Are you able to see the board? Okay, very good. B is equals to how much? We got 1. So A is equals to 1, C is equals to minus 1, B is equals to what? 1. Say this is equation number 1. Whatever the first equation we have taken, let us say that is equation number 1. Substitute A comma B and C values in 1. Substitute A comma B comma C values in equation 1. So what is equation number 1? M is directly proportional to F power A, T power B and V power C. So M is proportional to F power, what is A? A is equals to 1. What is B? T power, B is equals to 1. What is C? C is equals to minus 1. Are you getting? So this is the dimensional formula of what? M, or if you remove this proportionality symbol, you will get M is equals to K into F power 1, T power 1, V power minus 1. So this is the dimensional formula of M. Are you getting? Any doubt? So first what we have to do? M is depends upon F, T, V. Just I am write down. M is directly proportional to F, T, V. We don't know the dimensions, means we don't know the powers. I'm just taking A, B, C as a powers. So if we remove proportionality symbol, we will get constant. That is what? K. F power A, T power B, V power C. What is F? What is the dimensional formula of mass? M power 1. Dimensional formula of M is what? M power 1, T power 0, L power 0, because there is no presence of L and T. F means what? Force. This is a dimensional formula of force, power A. So T, this is a dimensional formula for time, power B, and velocity, distance by time. This is a dimensional formula for time. Okay, power A, power B, power C. I'm just expanded this power to all these things, and I'm just added all these things. If bases are same, then powers will be added. L power A, L power C, L power A plus C, T power minus 2A, B, C, T power minus 2A plus B minus C. So then what happened? I'm just compare the powers on either side. We got ABC values. So whatever the ABC values we got, just to substitute in equation 1, then it gives the dimensional formula. Easy one. Any doubts? Right. I hope that you don't have any doubts. But do the problem carefully. So if do any small mistake, if you will do any small mistake, so you will get a wrong answer. Okay? Right. Let us see one shortcut. Shortcut, bolo sir, shortcut bolo. Okay, so what he is given? Mass is given. This mass is depends upon what? Force, time, and the velocity. Force, time, and the velocity. Okay, so what is force? We can write our equation for force is what? F is equals to m into a. So F is equals to m into, we have to find the dimension for this. What is acceleration? Velocity divided by time. Place the m here only. What is acceleration? The rate of change of velocity, v by t, right? So place the m here only, and bring this term to this side. If t comes to this side, it becomes f into t, and v comes to this side, divided by v. So we can write dimensional formula for m is equals to f power 1, t power 1, v power minus 1. We get the same thing, f power 1, t power 1, v power minus 1. Are you getting? How was the trick? Nice, na? Thank you. Is it clear? Right. 3, 2, 1, go. Right. I'm taking a second example. Okay. At this time, I'm taking a momentum P and the time and the area, and find the relation for energy. Find the relation for energy. Okay, pause the video and try the answer. At this time they are given energy is related to momentum, time and area. Momentum, time and area. We have to establish the dimensional formula for energy. Pause the video and try the solution. 3, 2, 1, go. Have a look. So energy is what? Directly proportional to P, T, A. We don't know the dimensions. Dimensions means powers A, B, C. Okay. So let us say this is equation number 1. Energy means what? Either it is kinetic energy or potential energy, whatever it is, or heat energy. So I'm just writing the dimensional formula for energy. M L square T power minus 2. Okay, energy, kinetic energy, half mv square, half mv square, m capital M, v distance by time square, L square t power minus 2. Are you getting? Right. Which is equals to momentum. What is momentum? E is equals to mv, mass into velocity, distance by time. So then its dimensional formula is what? M power 1, L power 1, t power minus 1 whole power a. So what is the next term we have? Time period, t power b. And next what? Area. What is the dimensional formula for area? L square power c. Right. So expand these terms. M power a L power 1, t power minus a, okay, so t power b and L power 2c, 2c, tb, m power a, L power a, t power minus a. So m power a, L power a is there, sorry, very sorry, L power a and L power 2c is there, L power a plus 2c. Here t power minus a, t power b, no time term, so t power minus a plus b. So what is this? M power 1, L power 2, t power minus 2. Are you getting? And just write these equation as it is. L power a, L power 2c, bases same, powers will be added, bases same, powers will be added. Are you getting? So now what we have to do? Compare powers on either side. Compare powers on either side. So m power 1, m power a, m power what? A is there, here m power what? 1 is there. So a is equals to how much? 1. We got a is equals to 1. So L power a plus 2c is there, which is equals L power 2 is there. So we can write a is equals to what? 1 plus 2c is equals to 2. If 1 comes to this side, 2 minus 1. 2 minus 1 value is how much? 1. So 2c is equals to 1 and c is equals to what? 1 by 2. We got c is equals to 1 by 2. Next, here t power minus 2 is there. Here minus a plus b is there. A plus b is equals to minus 2. What is the value of a? Minus 1 plus b is equals to minus 2. B is equals to minus 2. If minus 1 went to that side, it becomes plus 1. Minus 2 plus 1, minus 1. Just substitute the values of a, b, c in 1. Substitute a, b, c in 1. Equation number 1. So E is directly proportional to P power. A value is how much? 1. And T power, what is the value of B? Minus 1. A power C, what is the power of C? 1 by 2. Are you getting? So these are the dimensional formula of energy. P power 1, T power minus 1, A power 1 by 2. Are you getting? Right, pause the video and write the solution. 3, 2, 1, go. Let us see the shortcut. Sir, you bring shortcut for us. Right, I bring the shortcut for you only. We can write energy is equals to what? Half mv square. Energy is equals to what? Half mv square. So 1 by 2 has no dimensional formula. I'm just writing this equation as m into v into v. M into v into v. What is mv? M into v is nothing but what? Momentum. Mv is what? Momentum into v. So we got p, and next we have to get time and the area. Time and area we have to get. From this, p into what is velocity? Distance by time. Velocity is what? Distance by time. So bring this time to numerator. So it becomes p t power minus 1 into L. So we got p power 1. So nothing is there means p power 1 and t power minus 1. But here a power 1 by 2 is there. Here L is there. How to convert L into A? Are you getting? Are you getting? How to convert L into A? What is area? Area. Capital A is equals to what? L square. Length into length. Meter square. If square come to this side, A is equals to L square. If square comes to this side, it becomes root. Root means what? A by 2. A power 1 by 2. Therefore, we got E is equals to P power 1, T power minus 1, A power 1 by 2. This is the answer. P power 1, T power minus 1, A power 1 by 2. That's it. Like this, हो गया. Is it clear? So practice. So always don't keep hope on shortcuts. Please follow the method, but do the method carefully. If you made a small mistake, it leads to get a wrong answer. Is it clear? Right, pause the video and write all these things. 3, 2, 1, go. Right. So the next concept we have based on dimensional analysis, that is limitations of dimensional analysis. It is not important, but it has some points. So first one is we cannot able to find the constant values like a 2 pi and all these things. Okay. So we cannot able to find the trigonometric functions. We cannot able to take the trigonometric functions like a cos theta, tan theta, all these things. And we cannot able to find the logarithm values by using dimensional analysis. If more than physical quantities are there at a right hand side, it is difficult to find the dimensional formulas. Okay, right? So to find a gravitational constant like a dimensional constants is very tough. Okay, so these are the limitations of dimensional analysis. So this is the end of the today's session. We will meet on next lecture. So that is units and measurements, class number 05. In that lecture we are going to discuss about significant figures. Okay, until then stay tuned. This is Rakesh Kanaganti signing off. Jai Hind.